Um, Firstly, thank you, Gary. Thank you for your talk and your extremely eloquent argument. I do have a question though, and it's about the applicability side of it. So the actual practice of the ketogenic diet type, if that's okay. So your talk has displayed, it's placed the westernized diet pretty much as causal to the high levels of obesity and or diabetes across the world. What I would like to clarify on though is the exclusion of the other diet types. So for example, what about your Mediterranean diet, whereby countries who have the same level of increasing obesity and diabetes, it's generally due to the westernized pattern that's there. But what about these different cultures that had diets prior to that? So the argument you've portrayed seems to attempt to solve a westernized problem with a westernized solution. So I'd like to hear your opinion as to why other diet styles that include percentages 40 through 60% carbohydrate can't be used as a solution to your argument.
Okay, well, this is obviously a key point. So again, my first book on all of this, which was published as The Diet Delusion in the UK, was 500 pages because there's a lot to this argument that I'm trying to squeeze down into an hour. One of the fundamental observations, basically, as I discussed in the beginning, is this increase in obesity and diabetes. And in fact, chronic diseases, heart disease, hypertension, stroke, obesity, diabetes, cancer, Alzheimer's, dementia, at least everywhere in the world where populations transition from whatever their native population, whatever their native diet is or traditional diet is, to Western diet. So it's interesting. This was primarily a British observation because the British Empire had missionary and colonial physicians all around the world, and they were administering to local native populations, whether Aboriginal in Australia or the African populations in Africa or the Asian populations in Asia, and everywhere they were seeing the same thing, which is that the local white population, the Westerners, got the chronic diseases that they had studied in medical school back in the UK, and the native populations did not until they started eating the Western diets and lifestyles. And the question is, what is it about that Western lifestyle? So what could it be that would have the same effect to, say, Southeast Asians living on primarily rice and barley as it would have to Greek islanders living on, green vegetables, fish, and feta cheese, as it would have to pastoral populations like the Maasai in Kenya living on the blood, meat, and milk from the animals that they herd, to Native American populations and First Nations people and Inuit. So no matter where they are in the world, transition them to Western diet, you see obesity and diabetes appear. And the conventional wisdom became basically these people have too much access to food, they get fat because they eat too much, labor-saving devices prevent them from having to work as hard as they used to work for their food, so they get an energy imbalance, and then the obesity causes the diabetes, and then in turn, then there's a whole host of explanations. The saturated fat content of Western foods causes the heart disease, the salt content causes the hypertension. The meat content and the alcohol causes gout when that appears, and you get this sort of cluster of chronic diseases. The alternative hypothesis, which was a British hypothesis pushed by primarily a naval researcher named Peter Cleve, was that it's the refinement of the carbohydrates. So the first thing that changes when a population gets westernized, they start eating white flour and sugar. So you add white flour and sugar to any population, regardless of their traditional diet, and in fact, you cause first insulin resistance. And then once you cause insulin resistance, now if they're eating a carbohydrate-rich diet, it's the carbohydrates in the diet that's stimulating the insulin secretion, the hyperinsulinemia, and everything that follows. So for a high-carb, say, Southeast Asian diet, the problem is the sugar and the white flour. For a high-carb Mediterranean olive oil, feta cheese, green vegetables, and fish diet. The problem is the white sugar and flour. You remove those, you'll make those populations healthier. But then this is based as much on clinical experience as anything else. It doesn't seem to be enough to reverse the obesity or the type 2 diabetes that's already developed because of the presence. And another aspect of this is maternal transmission, intrauterine or epigenetic effects from mother to children. So as the mothers start eating these relatively high sugar flour diets,
But that isn't talking about the percentage balance of carbohydrates. So total agreement that different foodstuffs, snack type foods, refined sugars, sure. But if you're talking about, say, the percentage carbohydrate intake in total of a Mediterranean diet pattern and that of the westernized diet, sure, if one were following, I'm just using Mediterranean as an example here, you can substitute or any other example you gave in, then starts consuming the westernized diet, sure, you can see that within the statistics. Things change due to those snack type foods. But if you go back to the core of it, that's still talking about an overconsumption of all of the different elements and just tweaking the foodstuffs. Because if you rewind and look at, say, the Mediterranean diet pattern, there's still a fair percentage of carbohydrates being consumed on average, right, but without the obesity and diabetes epidemic until the westernized is introduced, which is just disputing the ketogenic diet pattern more than anything else.
Wait, I lost you on that last. Like I said, the Mediterranean diet, any diet is benign. So the carbohydrates are not the problem initially. Okay, so we have two different questions. What causes the obesity epidemics in populations, the increases in obesity, and with it type 2 diabetes and everything else, all the other chronic diseases, and then how to reverse them once they've been caused. Okay, so these are two different questions. The alternative hypothesis is the causes of sugar in the flour. Glycemic response and the metabolism of the fructose and liver cells and sugar. My gut feeling is it's the sugar triggers it, sugary beverages in particular, that causes insulin resistance, which results in hyperinsulinemia, and then you're, again, over-secreting insulin to the carbohydrate content of the diet. Do that to any population, and you'll end up with obesity and diabetes. They will respond differently depending on genotype. So Southeast Asians, for instance, get more visceral fat and show the signs of insulin resistance at lower levels of fat accumulation than do Caucasians, Europeans and Americans. The question then becomes, once you've manifested the obese diabetic phenotype, we think in genetic terminology. So we're asking the question, what is it about the environment that will trigger any genotype such that you increase the manifestation of the obese diabetic phenotype? And the answer is sugar and refined flour. And then once you've got that obese diabetic phenotype, how do you reverse it? And the seemingly best way to reverse it is ketogenic diet, removal of all carbohydrates. You can try, clearly there are people who stay lean and healthy or get lean and healthy just by, they'll say, I cleaned up my diet, I stopped eating junk food, whatever that means. So they'll cut down a little bit on their carbohydrate content, or they'll cut down on French fries and white rice, or, pick your carb. But clearly, the idea here is that a significant portion of the population are so predisposed to get obese or to stay obese and diabetic that for them, they need the negative signal of insulin deficiency. In effect, if they want to succeed, they need to get virtually all of the carbohydrates other than green leafy vegetables out of their diets. And that's a different question. That ultimately, we get into personal nutrition. The way I see it is the level of carbohydrates that people can tolerate without excess fat storage.
Okay, I have I have more questions, but I feel like we should probably let some of our audience ask questions too, and maybe I can jump back in on that genetic component in a minute. How about that?
Sure. Can I ask a quick one? I'm sorry for the audience to go first. Gary, you make like really strong sort of mechanistic arguments with the basic science or the bench science and historical examples, and I think that's a really compelling argument. But why, in your opinion, do you think it hasn't been not proven? But why do you think the evidence is still fairly weak in terms of the translational science from both like the work of studies like Kevin Hall's, but also what we see practically in terms of why do, for instance, vegan and vegetarian diets not produce large increases in body fatness when you would expect they would, given the level of carbohydrate consumption?
Well, again, it's okay. Let me think about how best to answer this. We have several fundamental questions that we're asking. So the first is, what's the cause of the excess fat that you guys have to then try and get off your patients or clients or friends or self? And that's a difficult. So these are the kind of studies that, for instance, Kevin Hall did and David Ludwig did, and the not-for-profit that I co-founded, the Nutrition Science Initiative, funded. So you have to design an experiment that can test the two hypotheses. So by that, I mean you have to understand the two hypotheses well enough that you could say, we think if we do this to these subjects, the energy balance hypothesis predicts this will happen, and the hormonal regulatory or the carbohydrate insulin model predicts that will happen. And we should be able to see the difference well enough in our experimental setup such that we can say that the experiment refuted one of the two hypotheses. Kevin Hall would say that when they did this experiment, even though they saw an effect that was not predicted by the energy balance hypothesis, so in that sense it refuted the energy balance hypothesis, the effect was small and it was transitory, so it didn't confirm the carbohydrate insulin model either, and therefore they're both wrong. And as the agency that funded the experiment, we said, well, we don't think it was a very good experiment. For in part, it was only 4 weeks long. It wasn't randomized. It was always considered a pilot trial. If you don't randomize, you don't know if the transitory effect that you think you saw was because of the lack of randomization or because of the actual lack of an effect. And so we would like to continue to try and design better experiments and to test it. And when a group at Harvard designed a different experiment, and they saw a very different response. So you end up with a situation where Kevin Hall and his colleagues, well, Kevin Hall particularly says the Harvard group did it wrong, and you have the Harvard group saying, well, the NIH group did it wrong, and you have us saying it's very difficult to do these kinds of experiments. What you learn when you do them is what you screwed up. And regrettably, the problem is, so in any science, this is where it helps to have a background in harder science. Any science requires sort of a continuous series of experiments and iterations where you do an experiment, you realize what you might not have taken into account, and then you redo the experiment to take that into account, and your colleague down the hall tells you of something else you missed, and you just keep doing this iteration until you get to the point where you believe there's no other way to explain your results. The problem with nutrition and obesity is the experiments cost 5, 10, 30, 40, $50 million. So people end up, they do experiments, they get their results, they claim they're definitive. And if you criticize the results, you're seen as a naysayer who doesn't want to accept it. In this situation, 2 experiments have been done to test the hypothesis in humans, and they saw different. One arguably, well, one was interpreted as refuting the hypothesis, one was interpreted as supporting it. In animal models, as I said, the animal models to me are clear. You animals will get obese even when half starved. I don't see how that could be an overeating explanation. Regarding the diet trials, that's a different issue, because now you have instead of trying to do experimental studies to determine whether or not a hypothesis is true or not, you're doing diet studies to determine what's the most efficacious, effective diet. And in that case, you just have poorly done, poorly controlled trials. So we know it's very difficult to keep patients on a diet, and they tend to fall off. The data shows that they tend not to follow the diets. And there's even a lack of understanding among the researchers themselves of what they're actually testing. And I have one more slide that I want to show you. So am I still sharing my slides? I am, right?
Yeah.
Yeah, you are. Yeah.
This is just to give you an example of the kind of misconceptions there are in the research community. This was a study that was published in 2008 that was actually seen as a trial of a low-carb diet versus a Mediterranean diet versus a low-fat diet. It was done in Israel at a research laboratory where they could at least control what the subjects ate for lunch. So they thought they would get good compliance. And the reason I put this slide up is because we tend to think, if you just think of the studies comparing low-carb diets to low-fat diets, you'll notice that the diet that's called a low-fat diet, so it's low calories, they restrict their eating of supposedly 570 calories less than they started after 2 years. But those 570 calories are made up mostly of carbohydrate restriction. So in a diet called a low-fat diet, they restrict twice as much carbohydrates than they do fat. And what's interesting about that is that so as soon as you put someone on a diet, even if they think of it as a low-fat diet, they're likely to stop drinking, for instance, sugary beverages and start drinking diet sodas. They're likely to stop drinking beer if they were drinking beer and replace it with light beer. They're likely to skip desserts, sweets, because they know that sweets are not part of any dietary, any weight loss diet. And so they'll make changes, even under a low-fat diet, that are consistent with carbohydrate restriction. And now you see very much the same effects. Actually, the low-carb diet did better in this study. But the study is technically confounded by the carbohydrate restriction in the low-fat arm. And both studies, both arms, and the question is the calorie restriction the cause of the weight loss, or is the calorie restriction an effect of the mobilization and oxidation of fats under the low-carb diet?
And I think that's probably the key question. And I don't really want to take up any more time from the other from the audience, but do you think that we're focusing on the wrong macronutrient here, in that when you shift carbs or fats, you inevitably change protein, and maybe that this debate on carbs versus fat will be better focused on protein intake?
Actually, I think that's a kind of Twitter phenomenon, more than a serious phenomenon. There's this protein leverage hypothesis that two Australian researchers have put forward. If you actually look at the data to support it, it's based on 4 or 5 studies in which anytime protein goes up, carbohydrates go down. Remember, we still have this other observation to make, the other observation we're explaining, which is the increase in obesity and diabetes worldwide whenever sugar and refined flour are added to diets. Or even in the United States, if you look at the numbers in the US, protein intake doesn't change that much during the course of the obesity epidemic. Fat intake, for the most part, are animal fats replaced with vegetable oils, and carbohydrate consumption goes up. But the idea that protein is the key new macronutrient, I'm not saying it's not important for the diets, but that it's key in weight control. The idea is it's key in satiety. And remember, as soon as we start talking about satiety, we start talking about why obese people might not regulate their appetites in response to the slow accumulation, 10, 20 calories a day of fat in their fat tissue. And even if they're not eating enough protein and so they're hungry, or we're still talking about the equivalent of, eating 2 gummy bears less. So one of my issues with all discussions of protein is the assumption is that foods without protein are not satiating, and therefore we eat too much of them. And I'm arguing that any hypothesis that's based on obesity being caused by eating too much calories is a failed hypothesis. Does that make sense?
It does, and I guess that I said I wouldn't take any more time, but sorry. At what point then do calories matter? Because I think we mentioned this on our Twitter discussion. If we're looking at sort of whole body level anecdotes and even studies, why is it possible? How is it possible for people on a ketogenic diet to gain body fat if they're like that slide that you showed about the insulin being chronically reduced? So presumably, if you're on a ketogenic diet for a long period, you would see a similar response. So why do we see these anomalies where people actually gain body fat on a ketogenic diet?
Well, the question is how many, it would be an interesting thing to study. Okay, so there's a whole host of, like I said, every hormone influences fat accumulation, and sex hormones do it powerfully. So as we get older, you restrict, you secrete less sex hormones, less testosterone, less estrogen, you store fat. Men do it, that's why we get fat around the stomach. One of the reasons women do it. There's a lot of reasons why people would get fat that is unrelated to diet. So even those individuals who are gaining fat when they're on ketogenic diets, assuming they exist, like I said, because they don't come to me. I wish they did, because I would like to understand it better. They only come to people who don't like ketogenic diets. And I'll clarify this. For my last book, The Case for Keto, one of the things I did was I interviewed around 120 plus physicians who, of the few tens of thousands, I estimate, who have now converted to this way of thinking and believe that, like Virta Health, the best thing they can do for their patients is get them off carbohydrates. In interviewing those people, I asked every one of them if they'd ever had an example of someone who got fat on a ketogenic diet. And I did find one, and he was a physician. Indian heritage, moved to the US. Like many of us who have trouble maintaining a healthy weight, he could give me his weight history. I tracked him down, I interviewed him. I came away completely convinced that this guy gets fat on Atkins. Not just a little bit fatter, but put him on Atkins for 6 months, he gains 30 pounds. And it's primarily fat, it's not muscle. I can't explain it, okay? But there are going to be, I also have no idea what the denominator is, right? So again, this is the kind of thing, you don't see it in clinical trials. Well, again, you see it in the kind of diet trials that, for instance, the Diet Fit study at Stanford, you see some people gain weight on the low carb, high fat diet, but what you don't know is whether they're complying to the diet or not. Clearly in the diet trials, go ahead.
Why don't we see more weight gain and obesity like veganism and vegetarianism have become very popular? You'd expect those diets, because of their high carbohydrate intake, to induce more increases in body fatness.
We don't know how much increases in body. Maybe you do. I haven't seen evidence, though the assumption is when you go vegan and vegetarian, you see this in the writing in that community, there's healthy vegan diets and unhealthy vegan diets. So a healthy vegan diet is a diet that also restricts sugar and white flour. And there's no sugary beverages, there's no sweets, there's no, an unhealthy diet includes them. So the question is, when people go vegan or vegetarian, I'm assuming, like I said, they also make other changes to their diet as well. And this would be a very interesting thing to study. one of my issues is all of these questions can be resolved with good experiments. It's one reason why I co-founded the Nutrition Science Initiative. It would be very interesting to study those populations without the bias that, for instance, the Seventh-day Adventists that advocate those vegan diets and that do so many of these studies bring to it.
I guess that's going to be a problem with research as these diets get more publicized, though, is that you get selection bias and also recruitment bias. So, for instance, I briefly mentioned to you, I did a short case study on a low carbohydrate diet for athletes. And one of the problems was that I kind of needed the athletes to enter into it with no preconceptions of what the diet would or wouldn't do. I think that might be a problem for research in the future, is that like we talked before we came on air about sort of tribalism and believing in one particular diet. And I think that might be an issue as these diets become more popular, and particularly as it's more sort of tribalized.
In a sense, it's always an issue, because if you think about, what you need for a successful drug trial to understand the risks and benefits of a drug is double-blind placebo control. And you can't double-blind a diet. You can't single-blind. You can't blind a diet trial, because these diets are very different in how they taste and what they're like, unless you want to turn them into liquid diets, but then you're changing the nature of the foods being consumed. And often these studies aren't placebo, and there's no, in effect, dietary control unless you're comparing two diets against each other. And then, like I said, you get bad adherence and compliance. Often could be because the diets aren't working and the people don't see the benefits. Could be because the type of people you're recruiting for the trials. It is exquisitely difficult to do these experiments right. The Predimed study is a classic example of a study that completely botched it. They forgot, in effect, to include a placebo control for the first 3 years of the trial. But the study is still cited widely as definitive evidence for the benefits of the Mediterranean diet, because it costs $20 million and nobody has an alternative.
Okay, yeah.
A lot of...
Yeah. Sorry to cut over you, Gary. I'm just conscious of trying to get through some of the, there's been quite a few questions come through. Okay. So do you mind if I just fire a few of these, and if you could try and keep the answer as brief as you can, just so we can get through as many, that would be really good. So the first one, is there truth in the absolute calorific need of the human body? For example, the 2,000 calorie per day recommendation. If the consumption exceeds this significantly, will it lead to obesity due to the insulin angle?
This is why it's so hard to answer these questions shorter. There's so many issues being attached. Even the idea that there's a 2,000 calorie a day, like say there's an ideal human and he eats 2,000 calories a day and maintains, 5'8", 150 pounds, 2,000 calories keeps him weight stable, or her weight stable. The idea is that depending on your hypothesis, they will or will not stay in energy balance. So if you believe in the idea that obesity is an energy balance disorder, you start that individual off on 1,500 calories, 2,000 calories a day, they're going to stay weight stable. And if you feed them 2,500 calories, they're going to get fat until their body size increases and their expenditure increases and they go back to being in energy balance. This alternative carbohydrate insulin model says that 2,000 calories is dependent on the macronutrient composition of the diet. So if I take out 200 calories of good French cheese and I replace it with Coca-Cola, I'm going to slowly create insulin resistance in this person. Their insulin levels are going to go up and they're going to start getting fatter, even if they maintain 2,000 calories. So one of the problems with the kind of argument I've been making is it has implications throughout all of nutrition and chronic disease research, to the level where you say, well, it must be wrong, because clearly they couldn't have all screwed up at that level.
Do you think part of the issue is that we're maybe talking about or dealing with different populations? Most of your talk was obesity focused, and a lot of the people that you debate with on social media are personal trainers and nutritionists that recommend and see results with a calorie counting approach, which they're not necessarily using on people with obesity. Do you think the difference in population is critical to this discussion?
I think that there's a great phrase that comes from the cognitive psychologist, Kahneman, I forget his first name, who talked about in his book, Thinking Fast and Slow, he has this phrase, YCADE, which stands for what you see is all there is. And it's one of the fundamental cognitive biases. Your perspective determines what you see, and what you see determines what you believe. And yeah, I think absolutely, I don't think it's a surprise that the people who disagree with me the most are people who tend to be dealing with bodybuilders and elite athletes and, even there's a fundamental difference, I believe, between the 5 pounds of excess fat that we all put on and take off, depending on how much exercise we do, and the general diet, and the cause of chronic obesity and diabetes. And I think that there's a world of people out there who are so used to dealing with like 5 pounds extra that they want to take off or lose. I have one of my closest friends in science journalism, went from 180 to 190, and he swears that he got back to 180 because he started doing 100 push-ups a day. And therefore exercise makes a fundamental difference. And I don't doubt that he went back from 190 to 180 when he started doing push-ups, but we're talking about the different phenomena, or a reversible phenomena versus a chronic disease state.
I think.
Yeah, no, sorry, Kat.
No, it's okay. I think the question of different populations or individual variation is a big one, and it also tackles a couple of the questions that we've got in the chat as well. And you touched upon it yourself, Gary, when you discussed the historical twin research to do with obesity, and then I guess I'll add to that the nowadays kind of your more nutrigenomic and nutrigenetic research. So I think with the answer you just gave, we all appreciate that there are various different population types, albeit those who are already obese, those who aren't, different cultures, everything, right? Metabolically healthy, overweight and obese as well. So in that, we can attribute some of that to individual variation in genetics. So do you think that there could be any individual variation in the insulin model you're proposing, aka not a one-size-fits-all approach?
Well, there's clearly individual variation, because you could say, look, put the entire American population or the entire population of the UK on a Western diet, and some people become obese and some people don't.
Yeah.
And so the conventional wisdom is the people did ate too much. And I'm saying the people responded to the carbs in such a way that the insulin drove fat accumulation. And so you have different mechanisms. I think the fundamental mechanism will be conserved throughout everyone, but clearly how we respond. So the question isn't how we respond in terms of how much we eat and exercise, or maybe some of us just can't say no to palatable foods and other people can, so that those of us who get obese, eat too much, and that's the individual variation. I think the hormonal regulatory model holds for everyone, but there will be fundamental differences in for instance, the insulin sensitivity. And then I've been leaving out the hormone glucagon entirely, and growth hormone also plays a role here. It's dominated by insulin, so it can be simplified by talking about insulin. The response of the fat cells and the lean cells, the response of the liver cells to the fructose that they have to metabolize, all of that will be different between people. One of the things that fascinated me about the identical twin studies, so these famous studies done at the Mayo Clinic in Rochester, Minnesota, and done at I think it was McGill University in Montreal, and they see tenfold differences in fat accumulation between, the twins tended to store the same amount when overfed. So you feed them 1,000 calories, you measure how many calories they need to stay in energy balance, and you force them to eat 1,000 calories extra. And again, this doesn't say anything. It's confounded by the type of calories and all these other issues. It makes it a bad experiment from the perspective of which hypothesis is right. But overfeeding 1,000 calories a day for like 80 days, and you see tenfold differences in how much fat people accumulate.
Yeah,
So
both intra and inter differences when it comes to twins. But even in the pathways of all those different hormonal pathways, insulin alone, glucagon, everything has already had hundreds, some if not thousands of SNPs on various genes showing this individual difference that we all have.
Right. Although keep in mind that the gene variation explained by the genome-wide association studies is like, what, 8% of the variance in obesity at this point?
The original GRAS studies, yeah. But nowadays, when people are putting all of those hormones together and any other associated factor with obesity, it's about building the algorithms nowadays. Now, I'm not fully supportive of this. Don't think the research is there yet either, but it is a whole booming research area that also needs to be considered.
It does, although even there you find some misconceptions that I find sort of stunning. So again, the problem is you've got now people who specialty is genetics, who know nothing. So I talked about the importance of knowing the history of the field and the fact that you're studying a science of fat accumulation. You should know a lot about the physiological regulation of fat accumulation. So you have people doing these genome studies, and they find that the genes that they've identified as having a high association, the SNPs having a high association with fat accumulation, are found primarily in the nervous system. So they then conclude that this says that obesity is a brain disorder, and it's caused by, there's something about, confirms their belief that the hypothalamus isn't properly responding to signals, maybe leptin or ghrelin or whatever, NPYY from the body, and it's not regulating intake. And they're completely unaware that the nervous system plays a significant role in lipolysis. So the lipolysis, letting fat out of fat cells, is also stimulated directly by the central nervous system. So you could have a disorder, you could have a gene associated with obesity that's primarily expressed in the brain, but it could be doing its work directly on the fat cell, not in how much somebody's eating or exercising, but in how much fat they're lipolyzing or when they're lipolyzing,
That's, yeah, very much, I suppose, with your expression studies, but the newer research, I suppose, over the last decade is more to do with genotype as opposed to expression. So not the same nervous system.
Well, in what sense genotype? I guess that's what.
Just genotyping for different genes. So not to do with expression in your nervous system, not to do with the hypothalamus, just what your genetic code says and then what epigenetic changes you can have on top of that genotype.
Yeah.
So moving away from expression.
Okay. And that's, again, obviously huge genetic differences. So there's huge individual variations. It runs in families. It gets worse with each successive generation. So that tells you there are epigenetic intrauterine effects that are critical. Ultimately, is someone going to find a way to manipulate their weight via diet? So the carbohydrate insulin model is talking about only the link to how is this affected by diet, and how can we manipulate our weight via diet?
I think some of this Kat's question, actually looking through the other questions, comes up here. Sarah says, is there a danger that we're advocating the same dietary advice for both those who are already obese and those who want to avoid obesity?
Is there a danger? There's always unforeseen consequences. The nature, half the story that I tell in the Diet Delusion is how this belief that saturated fat causes heart disease by raising LDL cholesterol, how the implication.
I guess the question is are we doing the same now with carbohydrates as was previously done with fats in terms of the demonizing of a single macronutrient for people.
Yeah,
but
it's possible. The problem is if we're right or not. So a metaphor I often use is criminal justice. Somebody's committed a murder. The murder in this case, the crime committed is the creation of obesity and diabetes in people throughout the world. In the 1970s, we got the wrong suspect. Okay, we thought it was calories and dietary fat. That was wrong. We implicated that suspect. The crime keeps, we put that suspect in jail. The crime keeps happening. We say, okay, it's got to be a different suspect. So the fact that we got it wrong in the 1970s doesn't mean we're wrong now. We might be. You could always be wrong. God knows.
Yeah, and I did note that one of the questions that just practically, and this comes up a lot again on social media, is that like low carbohydrate diets are probably the most known diets. And you said yourself that Atkins is the best-selling diet book. Mm-hmm. So more people are aware of it. More people go on low carb diets. So why are we seeing a continued rise in obesity and overweightness across the world if this is one of the kind of golden tickets to reducing body fatness?
Well, for starters, until people like me and Nina Teicholz came along, the assumption in the medical community was that these diets would kill people. So 20 years ago, when I started my research, I would often hear from people who say, oh yeah, I went on Atkins, I lost 60 pounds, but then my doctor said I was killing myself. So as long as the medical community is arguing against it, that could be explanation enough for why it has had a long-term effect. The other reason is you could make could have made the same argument with cigarette smoking for decades, which is we know cigarettes cause lung cancer. We tell people that cigarettes cause lung cancer. Why hasn't smoking come down more? Why haven't lung cancer rates come down more? And it turns out, if you look at the data in the US, the Surgeon General's, famous Surgeon General's report on smoking and tobacco was 1964. Cigarette smoking starts coming down in 1964. And lung cancer rates don't start to reduce until the 1990s. They continue to go up for 30 years. And part of that is just the time lag with cancer. Part of it is how hard
there's a lot of
to
confounders though there, isn't there? Like detection methods, early diagnosis,
well, there's
pollution.
Always, so the question here is, once you have a mother who's struggling with, in effect, insulin resistance and hyperinsulinemia, so an obese or diabetic mother, or a mother who's gestationally diabetic during pregnancy, or whose blood sugar is elevated during pregnancy, they're going to give birth to a child who's predisposed to be fatter and more diabetic when they get older. So you have an intergenerational effect that's driving this up generation to generation. You have a threshold effect where it could take 10, 15 years to really notice a difference. You could always argue against it. Even if it's, like I said, even if this hypothesis is wrong, what I would like to do is make sure that the energy balance hypothesis gets left behind forever, because that's not it's not an explanation of obesity, it's a description. And what we need is an explanation, something that explains why people accumulate 10, 20, 30 calories a day in their fat tissue and why other people don't.
I guess another thing that comes up is why, when people apply energy balance in practice, i.e. calorie counting, do they often get good results in terms of body composition? And again, this is something that I know you're challenged on quite a bit when it's kind of anecdote wars. You've got the low carb crowd saying, well, look, I didn't focus on calories at all. I just cut my carbohydrates and I lost a lot of body fat. But then you've got the people that are trying to practically apply calorie counting by tracking their energy intake. And you do see it in people that are professional at losing body fat, i.e. physique models and bodybuilders, natural bodybuilders as well. They tend to use that approach. And if the physiology applies across the board, then why is the practice of calorie counting if done like as accurately as possible? Why is it so effective?
Okay, again, that's a long. First of all, there's.
I know. So sorry for the long question.
First is the calorie or carbohydrates issue that I discussed in this slide that's still up. Okay, so, well, maybe it's not up anymore, but it's just.
You just took it down, I think.
Yeah, I clicked on it and it slideshow and window. Share screen. Here we go. This one.
Just while Gary looks for the slide, people that are still with us, what we'll do, if it's okay with Gary, because I've got quite a few more questions. If maybe we can answer these offline in an email, I can
we could also together. Let me just, most of us who became, virtually everyone who ends up in the low carbohydrate mindset in this religion got here because eventually this was the only thing that worked for us. So when I was in my late teens, when I was in college, I played American football, right? So in American football, I was a lineman, defensive lineman. So the idea was to be as heavy as possible. And I could get up if I ate constantly, which I did, and a lot of carbs and a lot of sugar and a lot of everything, I could get up to almost to 240 pounds, whatever that is, about 120 kilos. And then when football was over, I did the calorie restricted diet. So I ate less and I lost 30 of the pounds, and I maintained that weight loss over the course of my 20s by, whenever I started gaining weight again, cutting back on the amount of food I ate. Eventually you get to the point where you're constantly restricting the food you eat and the weight is coming on anyway. And that's when you start to try a vegan or vegetarian diet or whatever quack diet book you read that week, or eventually you get to keto. But the point is, one of the observations in all of this is that if you're physically active enough and you're young enough, then you can basically withstand the constant thoughts of food that come with calorie restriction, you can lose the weight just by eating less. It's not satisfying. There's nothing. You never feel sated. One of the people I interviewed for my book, and I become good friends with this young man, is a graduate, has a law degree from Yale, who weighed 400 pounds when he was 18 years old. He grew up morbidly obese. And when we were dating, she said there was never a day in his life that he wasn't hungry, despite weighing 400 pounds. And there was never a day in his life where he felt sated after a meal. So now you tell that person to eat less. It doesn't mean he couldn't get down to 350 by doing it, but you have to deal with a sort of constant state of deprivation and hunger. And there are studies I talk about in my books that have been done on lean individuals, the famous Ansel Keys starvation studies in World War II. The difference with the ketogenic diet, and the argument is if you do this by lowering insulin rather than semi-starvation, you mobilize the fat so you could use it for energy, and your lean cells will burn it for energy if insulin is low, and now you don't feel hungry all the time because in effect you're eating your own, the calories you've stored until now have been unavailable. So again, it's a long story, but the difference is basically, one diet will work for some people as long as they could sustain, keep on it while feeling hungry all the time.
Yeah, I think that's one of the crux of the debate, isn't it? Is what's sustainable for one person is not sustainable for another. But then if we start attributing a mechanism to that lack of sustainability, I think that's where it gets confusing for people.
That's why I think it's easier if we remember that we're talking first about the cause of obesity. Mm-hmm. So if we can establish what it is that's the cause of this excess fat accumulation that clearly many people cannot stop from happening. That's why it helps to be predisposed to gain weight, because it's easier to understand what it's like to get fatter almost regardless of what you do. Than it is to be like a lean, I could start bodybuilding tomorrow, and unless I do, growth hormone and testosterone, I'm always going to have more fat than, say, Elaine Norton. And the question is why? Even if I starve myself, that fat isn't going to go away. And if I starve myself, it's going to inhibit the building of the muscles. So the question is, we know the building of the muscles requires hormones, but the fat is still left to this idea that's just about energy balance. Pat, you must have a question, because I'm not sure Paul is reading anymore. I think he's...
Yeah, sorry. I was saying to the rest of the audience that that there's a few that have come through, and I don't think well, I at least have not got time to go through all of them. So I was wondering if maybe we could put some email answers together for these questions and then send them out to the audience.
Yeah, I would be happy to do that.
Oh, sure. That's brilliant. Thanks. Just one final one. I'll just get through this one. Actually, this raises an interesting point. It's why is fat loss not actively being encouraged to help the fight against COVID instead of, I won't go on to what they think about vaccination. But on that point, Gary, does it frustrate you that, or what do you think of quite a few of people in the low carb community have sort of started advising or viewing their opinions on vaccination and being deemed as quacks? Has that frustrated you in someone who's an advocate of low carb diets, that sort of people have got out of their lane?
Yeah, there's a tendency when you're arguing against conventional wisdom to attract people who find it easy to disbelieve conventional wisdom everywhere. And so you attract people who may not be quite as critical thinkers as you would like, but nonetheless, they're willing to believe you're right, and then they're willing to believe that the Earth is flat and that Mars has canals on it, and anything else, that challenges conventional thinking. I've argued with my friends that I wish they would that we can only afford to fight one battle, that it's desperately difficult to keep credibility in this world when you're arguing that, the conventional thinking is wrong, that the medical research establishment has made a terrible mistake. And if you do it in more than one field, if nothing else, you look like a knee-jerk denialist. And at the worst, you're perceived as a quack when you're not perceived that way. And then that feeds back into how your arguments about the cause of obesity and diabetes and low carb diets. So yeah, I find it a little dismaying. I don't know enough about it to know when they're right and wrong. I do know that when I ask them critical questions, I don't get answers that satisfy me.
It's just a trend I've seen, and I imagine it is quite frustrating, because, as you say, you kind of fight in one fight, and people are kind of confounding another issue, and it dilutes the argument you're trying to make on your subject.
And again, for all I know, they're right. I don't think so, but I know it took me 5 years to come to conclusions I felt I could trust, studying the obesity nutrition literature.
Well, exactly. And I wonder, if we look at the history of some of the people that are now commenting a lot on vaccines, if you look at their backgrounds and what they've tweeted on before, how you can suddenly become an expert in viral epidemiology is kind of beyond me. So I kind of try and stay in my lane, although some would argue by discussing I'm outside.
I completely agree with you. And as for the first question about advising people to lose weight, what are you going to tell them? My counter argument is that when the COVID pandemic passes and more people are going to be dying from the negative sequelae of obesity and diabetes prematurely than die from COVID at its worst. And so this is what we should. And again, one question I asked, why don't we have that kind of obsessive interest in fixing this problem rather than, a dozen of us arguing on Twitter? There's something very wrong with our public health responses to these disorders. Well, and in part it's because we think they're behavioral. So we know what the truth is. We just, these people who suffer from obesity don't listen to us.
I mean, and I must end this now, but that was another question. I don't know whether it was by accident, but on one of your energy balance slide, you'd circled the person's head, and I was going to ask you a question about the brain and its role in or how you see its role in adiposity. But I think we're done for time now, and I've taken up enough of your time, and I can see the participant list is gradually declining.
Okay,
so
yeah.
On that, I just wanted to say thanks very much for giving your talk and spending extra time answering questions. And thanks to everyone who's joined us this evening. I hope you found it really useful. I'm sorry we weren't able to get through all of your questions.
Yeah, thank you very much, Gary.
Okay, thank you guys for being open to this and having me. Okay,
Cool.
Take care.
I'll speak soon. Thanks. Bye.